Logical files, as we have seen in the first chapter, do not contain any data. They are used only to view the data records that are in the physical files in formats that might be different from the way in which the records are actually stored in the file. Programs that use logical files will see the data in the physical file as per the format of the logical file. By selecting only the necessary fields, we can prevent end users from having total access to the information in the databases, thereby providing a level of security. DB2400 supports various relational operators that can be used to select the data from the physical files. They are sequence, select, project, union, and join. Let us take a quick look at these relational operators. The sequence operator. This is used to logically sort the file based on the value of a particular field. For example, when we sequence the file A on customer name, the records will be retrieved from the customer file ordered by customer name. Remember, the records in the customer file remain as they are, while the logical file will contain the relative record numbers of the records in the desired sequence. The select operator. This operator is used to select a subset of records from the physical file. For example, from file A, we can select only the records of customers who reside in Baroda city. The project operator. This operator is used to select a set of fields from the physical file. Only the selected fields will be visible to the application using the logical file. For example, we can say select only the customer name and city from file A. The union operator. Sometimes multiple files are used to store data instead of a single large file so that the individual file sizes can be kept small in order to optimize performance. The union operator is used to combine the records in two or more physical files to give you a single set of records, as you can see here. DB2400 supports two forms of the join operator, an inner join and a left outer join. The inner join will combine or join all those records from the first file that have at least one matching record in the second file. As you can see in this example, the record having customer ID C0005 in file A is not included in the output since there is no corresponding record in file B. The left outer join will include all the records from the first file. In case a matching record is not found in the second file, default values will be used for the fields coming from the second file. Let us see how logical files are coded. Take the same customer physical file that we saw in the previous chapter. Now, say an application requires the following fields from the physical file: customer ID, customer name, and city. Also, the application requires that the records be sequenced on the city field. Let us see how to code the logical file so that it meets these requirements. As in the case of physical files, we code a record format name in columns 19 to 28 along with an R in column 17. In the function column, we code the pfile keyword to identify the physical file that contains the actual data. Next, we list out the fields we want to include in the logical file. Then, we define the key field city by putting a K in column 17 and the field name in columns 19 to 28. This completes our requirement. Now we can create the logical file. Applications using the logical file will see only the fields that are coded here. Now, suppose an application requires all the fields from the physical file but sequenced on the customer ID field, we could code the logical file like this. Here, we use the same record format name as in the physical file and specify the pfile keyword along with the name of the physical file. Next, we identify customer ID as the key field on which to sequence this file. This is all the code that is required. When we do not specify any fields in the logical file, we are sharing the record format of the physical file. The select omit logic can be used to select a set of records that match a criterion. Select omit entries are placed after the key field specification in a logical file. For example, to select only those records of customers who reside in Mumbai city, we code an S in column 17 for select. We code the field name city in columns 19 to 28, and in the function column, we code the compare keyword. The value of the city field in each of the records will be compared with Mumbai and only the matching records will be selected. The omit logic works in a similar manner. We can, for example, say omit all records where the city is Mumbai. As we just saw, the compare keyword takes two parameters, a relational operator and a value or field name. The relational operators that we can use with the compare keyword are less than, not less than or equal to, greater than, not greater than or equal to, and not equal to. The range and values keywords can also be used with select omit statements. The range keyword takes two values, the lower and upper limits that have to be tested for. For example, here we say select all the records where the balance amount is between 20,000 and 60,000. The values keyword can take a set of values. For example, here we are selecting all the records where the category field has a value of A or B or C or D. You can have multiple select omit statements by listing them one after the other like this. DB2400 will start with the first condition and test each one in turn. First, it will omit records where the category is A. Next, the remaining records will be tested for the second condition, that is, where the city is Mumbai and the matching records will be selected. What happens to the records that have neither been omitted in the first step nor selected in the second? By default, if the last specification was select, the remaining records will be omitted. And if the last specification had been omit, the remaining records would have been selected. This is called an implicit all condition. You can also have an explicit all condition coded like this after all the select omit statements. The explicit all condition can have either an S or an O to either select or omit the records that do not satisfy the earlier select omit statements. This was an example of an OR condition. Let us look at another example. Here we are selecting all records where category is A and city is Mumbai. In the second select statement, we leave the column 17 blank. The system will select only those records meeting both the criteria. This is an example of an AND condition. Next, let us look at the dynamic select keyword. This is a file level keyword. When the dynamic select keyword is used, the select omit entries are tested only when an application is reading the records and are not maintained over physical files. Here, the logical file access path will have entries for all the records. Next, we move on to the reference access path keyword. This is a file level keyword. It specifies that the logical file has the same access path definition as the referenced file, that is, the same key field definition and select omit logic. Next, we will look at three field level keywords: rename, concatenate, and substring. The rename keyword is used to rename a physical file field to suit high-level language programming requirements. For example, here we are renaming the city field in the physical file as custlock in the logical file. The concatenate keyword is used to combine two or more fields from a physical file to form a single field in the logical file. For example, here we are concatenating location, street, and city fields in the physical file into a new field address in the logical file. The concatenate keyword can only be used with character fields and zoned decimal fields with 0 decimal places. The substring keyword is used to extract a portion of an existing field in the physical file. Here we specify the field name, starting position, and the number of characters to be extracted. The resulting field has to be a character field and can only be used for input. Suppose in the customer physical file we have names stored in mixed case and our application requires the names in uppercase. The translate table keyword can be used to translate the mixed case characters in the physical file into uppercase characters. Here we need to identify a translation table that is to be used to map the field in the physical file to the corresponding field in the logical file. Here is a listing of all the keywords that we can use with logical files. As you can see, some of the keywords are the same as those used with physical files. These keywords have the same function when used with logical files. You can click on any keyword to get the detailed information for that keyword. The process of coding and creating a logical file is the same as that of physical files. Here, you use the create logical file command instead of the create physical file command. This command takes a number of parameters that are identical to the parameters of the create physical file command. Let us take a quick look at some of them. On the file parameter, we specify the name of the logical file that is to be created. The source file parameter takes the name of the source file containing the DDS code. The source member parameter is used to identify the particular member in the source file. Normally, the source member has the same name as the logical file. To modify the data definition of a logical file, we can delete the logical file using the delete logical file command and modify the DDS and recompile it. Let us now move on to join logical files. Sometimes an application might require fields from two or more different physical files. Join logical files allows us to combine the required fields from different physical files into a single logical file that can be used by any application. A join logical file can have only a single record format and is read-only. We cannot update a physical file through a join logical file. Say we have two databases, a customer file that has customer ID and customer name. We also have an order file that contains order ID, item code, quantity, total amount and customer ID. An application is used to generate a report in this format. The required fields are customer name from the customer file and the corresponding order ID and total amount from the order file. We need to create a join logical file that will supply the required fields to the application. To create a join logical file, we need to have at least one field in each of the files whose attributes are identical. Here, we can join the files on the customer ID field. Let us look at the DDS coding for the join logical file. As usual, we begin by defining the record format along with the required fields. In the function column, we use the joined files keyword to identify the physical files which have to be joined, that is customer file and order file. At least two physical files have to be mentioned. We can specify a maximum of 32 files. The first file in the joined files list is called the primary file, and the others are called secondary files. Next, we have a join specification identified by a J in column 17. Each J specification will join two files identified by the join keyword. This keyword is optional when only two files are to be joined. The join field keyword is used to identify the fields on which the two files are to be joined. The field from the primary file is listed first, followed by the field from the secondary file. when the same field name exists in both the physical files, for example, order ID, we use the join reference keyword to specify the file from which the field is to be taken. For example, here we say that the customer ID is to come from the customer file. Different situations may arise when joining physical files. Let us look at each of them. The first situation is a primary file record that has no matching secondary file record. In this case, DB2400 will by default skip the primary file record. However, if the joint default values keyword is used, DB2400 returns the primary file record with default values for all fields from the secondary file. Another situation. A primary file that has two or more matching secondary file records. In this case, you can use the join duplicate sequence keyword to specify the sequence in which you want to retrieve the records. The field that is used to join the physical files need not be a part of the join logical file. For this, we code an N in column 38 to specify that the field is neither an input or output field and will not appear in the join logical file. A special case of joining files is when you join a physical file to itself. Consider this example. A record in an employee file contains the employee ID, the employee name, and the employee ID of his manager along with other fields. Now, suppose we want to generate a report where for each employee we have his employee ID, his name, and his manager's name. Since every manager is also an employee in the company, we can use the manager employee ID to search the file for a matching record with the same employee ID and retrieve the employee name. Or we could use a join logical file to join the physical file to itself. Here is the DDS coding for this type of join logical file. At the record format level, we code the joined files keyword specifying employee for both the primary as well as the secondary file. Next, we come to the join specification. When coding the join keyword, we cannot use file names as they are the same and the system will not be able to identify whether we are referring to the primary file or the secondary file. Hence, we use the relative file number of the file in the joined files keyword with the primary file being 1, the next file 2, and so on. With the joined fields keyword, we specify that the manager's ID from the primary file is to be matched with the employee ID in the secondary file. Each of the fields in the join logical file will require a join reference keyword as the fields exist in both the files. Since we require both the employee's name as well as the manager's name, which in the file is actually the employee name field itself, we need to rename the employee name field in the secondary file. We also specify join reference with a value of 2 to indicate that the field comes from the secondary file. Also, we specify the join default values keyword at the file level. This will ensure that no records are left out from the join logical file in case some employee does not have a manager to report to. This might be the case with the director of the company. Let us now see how 3 or more physical files can be joined together. First, we use the joined files keyword to list the files to be joined. The first file in the list is the primary file. The remaining files are secondary files. We can specify joins between any 2 files. The first join has to have the primary file as the first file. For example, here file A is the primary file. Any of the secondary files can be named as the second file. Now we can join file A to file B or file A to file C. Each secondary file can be listed only once as the second file in the join specification. Subsequently, a secondary file can be specified as the first file on a join entry. For example, we can say join file B to file C. As you can see, the files have to be joined in the same order as they are listed in the joined files entry. For example, we cannot say join file C with file B. To be able to do this, the joined files entry should have file C listed before file B like this. Here is an example. We have a customer file that has 2 fields, customer ID and customer name. We also have an order file that contains 4 fields, order ID, item code, customer ID and quantity ordered. We have an item master that contains the item code and item description fields. Now consider an application that is going to generate a report. For each order, it is going to print the order number, the description of the item sold, the customer name and the quantity ordered. We can create a join logical file based on these 3 physical files. Let us now code the DDS for the join logical file. To begin with, we will code the record format name with the join file keyword to identify the files to be joined. We follow this with a list of the required fields. We can join the customer file with the order file to get the customer name and quantity ordered. The files can be joined on the customer ID field. Next, we join the order file with the item file to get the item description. We use the item code to join these 2 files. We add the join reference keyword to identify the file from which a field should be taken in case it appears in more than one file. This completes the required coding for the join logical file. With this, we have completed the chapter on logical files. Summary. Logical files are used to provide a view of the data in the physical file in different formats. We can select only the required fields from the physical file. We can also select a subset of the total records in the physical file by using the select and omit specifications. We looked at various keywords that can be used with the logical files. We also saw how we could combine data from different physical files using join logical files.